Hello all and welcome to my channel DevOps Mela. This is Rohit Singh. And again, welcome to my interview question with practical solutions series. So based on public demand, here I am with Kubernetes question set. This is the part one guys. Based on your comments, your suggestion, I'll come up with part two as well and part three, so and so forth. For now, let's start with part one. Now, before I start with Kubernetes, let me tell you, I have already set up the Kubernetes cluster. If you want to know how do we set up a Kubernetes cluster, that is something I have already covered in one of my previous video. You can find the link in my description or in the top hand right side corner. Okay. So today, let me take you to my cluster first. This is the cluster which I have set up. So basically, if you look into it, I got my control plane node up and running, and all my scenario based questions will be done over here. Okay. Now in my video wherein I have taught how do we set up cluster, that is manual I did. So each and every step was done manually. But if you want to have this thing automated, this is the automated script which I have right now, which I have created. If you guys want it, I will put it in my GitLab. You can take it from there. Okay, you can find this link even in the description. Okay, let's get started with the interview question, guys. Again, I'm reiterating the interview questions will be completely based on my experience of taking interviews and giving interviews and what exactly is the demand in the market. So these questions are completely based on that. Please feel free to give me your suggestion in the description and the comment box. Okay, so let's get started and let's see what is the first question. Now the question is, what are the different components of master and a worker node? Now many of you will say this is not a scenario based question. So this is a very important question if you're going for an interview and if they're asking anything on Kubernetes, this is something they will definitely ask. Okay. So let's see what are the different components we have. So okay, for starting with control plane, you can call it as master node. So control plane has many services. The very important services is API. So these are the component which is running on the master nodes or the control plane node, whatever naming you want to give. So API server is a component of the Kubernetes control plane that exposes API. So all the interaction happens through this API server. Then we got something called etcd. Etcd is basically it's a consistent and high available key value stored used in Kubernetes. So basically this is the Kubernetes database. Then we got the scheduler. So scheduler is basically it's a control plane component that watches for newly created pods with no assigned node. So basically all the pod scheduling is done by this scheduler. So when you put in your config for creating some pod, that goes to the scheduler, and the scheduler is basically responsible for placing that pod wherever the nodes are available. Okay. Now then we got something called control manager. So there are multiple controller process which is running. For to name few, you can call it as node controller, responsible for noticing and responding when the node goes down. We can have job controller, watches for job that represent one of the tasks. You can have endpoint controllers. So endpoint controllers basically populate the endpoint objects. So there are many controllers you will find out. So control manager basically handles everything. Now you got something called cloud control manager as well. Like suppose if you want to store your data and if you want to make your volume persistent and you want to store your data somewhere on cloud like S3, Azure storage account and all, so you can make use of cloud control manager also. So this is definitely optional. Okay. These are the four important components on Masternode: API server, scheduler, etcd, and control manager. Controller manager. The controller there are multiple types of controller, as I said. Now moving on to the worker node. So worker node, very important. We got the container runtime. So this is the container runtime engine. is a software that is responsible for running your containers, guys. Okay. Then we got something called Kubelet. Kubelet, an agent that runs on each node in the cluster. It makes sure that the containers are running in a pod. So this kubelet is the pilot of the ship, making sure that the pods are running. Then you got something called kube proxy. So kube proxy, you can call it as network proxy, that basically runs on each node in your cluster, and basically it will help you implement Kubernetes service concept. So all the interaction and everything will happen using this kube proxy. Okay. Again, reiterating, what are the different components we find on master and the worker nodes? Master, API server, scheduler, etcd, controller manager, and worker, container runtime, kubelet, kube proxy. Make sense? Okay, let's move on to the next question. Okay, the question is, we have recently created a Nginx pod and the status is pending. So I have created a Nginx pod, but the status is pending. Now we need to go and find out why. Okay. Now how do we find out? So let me show you the pod first. So kubectl get pods. So if you see, this is the pod, Nginx web app. Okay. And it's not ready yet. The status is pending. It was created around 10 minutes ago. Okay. Now how do we find out? Let's see. So basically we can run the kubectl describe command. Now describe command provides detailed information about the pod, guys, such as what is the state, the labels, the condition, the volumes, and all very important, the related events. So when you run a pod, so there are bootstrapping events which occurs, like fetching the image, creating a pod, all this happens. So if something is stuck somewhere, so describe command should be the first thing what you should do. Okay, so when you describe a pod, then you'll get a fair idea what exactly is wrong with the pod. Okay, let's go and see that. So kubectl describe pod and the name of the pod. So if you go and see from the top, this is all information regarding in the describe command, what you get, everything related to your pod. Coming down, this is the place where the events are. Okay, now when you see in an event, there's something called warning, the type. The reason is failed scheduling. So basically the scheduler was not able to schedule the pod. So default scheduler we are using, the message is 0 out of 1 nodes are available. One node had untolerate taint. Now this is the concept of taint and tolerance comes in picture over here. For now, this is my control plane server. I have not created any worker node over here. This is the master node what I have right now. And by default, on a master node, you cannot go and deploy your pods or deploy your application. You cannot go and create the pod. It's only the control plane component services would be running on your master node. So by default, you cannot go and create anything as such. That is the reason scheduler was not able to, basically it was not able to assign the node to you, and the pod is still in pending state. If you see, 0 out of 1 nodes are available, one presumption is not helpful for scheduling. So scheduler is not able to deploy your pod on this particular node. Now if you want to see the status, how do we check the status of the taint and all? So I can simply go and look into kubectl get nodes, and I can simply do kubectl describe node. We can even describe a node, kube vm, that is the name of a node. I can simply do a grep -i and look for the word taint. Now if you see this, I got taint set on this node, which is saying we cannot schedule, no schedule. Okay, what we can do now, if you want to deploy your pod on this particular node, we can remove this no schedule thing. How do we do it? So there is a command. Now what exactly taint intolerance I'm not covering in this particular scenario, but don't worry guys, taint intolerance is a very important topic. I got a scenario based question based on taint intolerant also in my upcoming slides. Okay, don't worry. So let's go ahead and remove this taint, kubectl taint, and I can just give node. I can give a node name or I can just use a flag all, and I can just copy this part till here. Okay, and at the end I can just use a dash. This is basically will remove the no schedule taint. Done. Now this VM, this particular node is untainted. What does that mean? That means my pod will get created now. See, it's running. Let's quickly see the event. Describe. Okay, now if you see this, created successfully. So we do have a Nginx web app running successfully. Okay, so this is how you will troubleshoot and you will debug and you'll try to find out what exactly is wrong with your running pod. Okay, let's move on to the third scenario. Okay, let's move on to scenario 3. Now the scenario is previously created Nginx web server deployed successfully, okay, but the web page is not accessible. Find out why. Okay, so the question is the Nginx web server which we have created previously was deployed successfully after removing the taint, but the web server is not, the web page is not accessible. The reason? Now let's go and see whether we have created the services or not. Okay, I do have the web server and I do have a service created which is related to the web server. Okay, now I can go and look into this service. Okay, so it has a label Nginx web app, so it's perfect. I can do a describe also guys, there's no need to edit. So I can do a describe over here also and I can verify the same. So we got a Nginx label over here, so it should work. Listening on port 8080. Perfect. Let me try to access this web server. So I can do a curl http localhost because this is the only port running on. So let's use localhost, and the service which we have created is a type node port. So this is the port I can try to access on my web server. So this is the error what we are getting, failed to connect to localhost, connection refused. So let's see how can we fix this issue, and firstly how do we debug this issue. Okay, let's see what we have. So check the pod events by running the describe command. Let's go and see that. So let's see if we have any issues with the pod. So the first thing first, check it through a describe command. Describe pod. I do have the pod name. Now in the describe, do we see anything, any event? Created Nginx web app, started connect container Nginx web app. So it looks good. My container is running, so there's no issue over here. What is the second thing we can check? Check the web server logs. Okay, this looks good. Now let's go and see the logs. kubectl logs. Name of the web server is Nginx web app. This is the command. Okay, so let me see if I see anything in the logs. Getting the checksum. Enable the listener. Oh, nothing in the logs. So this is the default config of my Nginx web server. Can we go and check this inside the container? Yeah, that should be my third step. So try analyzing the error. We have already seen the error. It's something related to network. Okay. So check web server config by kubectl execute command. So let's go. That is the only path left for us. We can go into the Nginx web server config and see what's wrong there. Okay. So this is the path nginx config d execute.config. Now this is something we need to go inside the container. So what is the name of my pod? Nginx web app. So the command should be kubectl execute pod, and the name of the pod is nginx web app. And what is the command I want to execute? So let's go and execute this command cat. Oh wait, no need to give pod, just give nginx web app. Okay, now we are inside it now. Now this is the path where the index.html file should be. Okay, very important. The server is listening on port 80. Now the target port should be port 80. And what did we define in the service? The service what we have. So this is the service port. Let's go and see what we have it over here. kubectl describe svc. The target port is set to 8080. So basically the request is coming on port 8080, and in the backend also the request is going on port 8080. But my web server is listening on port 80. Either I can go and make changes to my web server config, or I change this thing to 80, and I think it will work after that. So what I can do, how do I edit? So you can make use of this edit command, kubectl edit svc, not this. Let's copy this name. Okay, come down and change this target port from 8080 to 80. After changes, it will get implemented automatically. So let's describe again. Target port is 80. Now let's try and access, not kubectl, try and access the curl command again. Perfect. Welcome to DevOps Mela interview preparation. Now it's working. Now this is how step by step, guys, you can debug things whenever you face some challenges. So this was a network issue which I have showed you. There could be multiple other issue. So describe, checking logs, checking the application config, web server config, all those files. This is one step at a time, and you can come to a conclusion like what exactly wrong with your working pod. Okay, moving on. So that was my scenario 3. Now let's have one more. Let's go on and see the scenario 4. Okay, so the Nginx pod created in the previous scenario crashed. Okay, and the config index.html file was deleted. How to avoid similar events in future? Okay, let's go and see if the Nginx, the server which we have created, is it still available, or it got deleted. Let's go and see that. Okay, let's go and see it. kubectl get pods. Okay, no resource found in the default namespace. So somehow my pod which was running my application, my web server basically, it had some custom config. This is index.html is one of the example. Even that file, the configuration got deleted because of some XYZ reason, the pod has crashed. Now, as we were not using persistent volume concept, okay, so by default, Kubernetes pods are immutable. That means if by some reason if the pod stops or crashes, your data will be lost. So how do we avoid similar events in the future? So the only solution is by making the volume persistent. So this is your pod. Inside the pod you have your container running. You need to make this volume, so basically whatever you're storing in this, may store it somewhere so that even though if this pod gets deleted, your data is still intact. How do we achieve this? This can be achieved using the concept of PV. So PV is basically persistent volume. So persistent volume is nothing but it's a piece of storage in the cluster that can be provisioned by an administrator. A Kubernetes administrator can provision these PVs, or it can also be created dynamically using storage classes. Okay, so both the options are there. The benefit of using persistent volume is it's independent of the life cycle of the pod. So what does that mean? It means even the pod shuts down, crashes, the data in the volume is not erased. Okay, the example what you see, I'm using a local hard drive, my hard drive. So this is my local HDD on the server itself. And on this local HDD, imagine I have created multiple PVs. Okay, I have multiple persistent volume created. This is something, just imagine I've pre-created. So there, I got this persistent volume created. It has different storage class. It has different access mode. I got different uh, storage created. So based on different criterias and parameters, I've created the PV. Now, how exactly a user can request this PV or they can use this PVs basically. So this can be used. They can call this PVs with a claim form. They need to create a claim form that is known as PVC. So PVC stands for persistent volume claim, is a request for storage by a user. So the administrator, or not administrator, the person who is deploying the application, and if he wants to use persistent volume, he can create a PVC. He can write a PVC form, and this PVC form will contain parameters such as storage class, access mode, whether you want read, write, read only, and things like that, and storage. And there are many other parameters also. For now, these are the three important parameters what they will ask for. Now, what Kubernetes will do, Kubernetes will look for a PV that meets the criteria defined in the PVC. Now, if you have defined some storage class, manual, imagine, access mode, read, write, storage, you want 1 GB. So this is the criteria which you have defined in your PV. Now, what Kubernetes will do, it will look for matching PV for you. So suppose Kubernetes has found that PV3 is matching your criteria. Now what Kubernetes will do, it will go and assign this PVC. Basically, it will assign this PV to your pod. And this process is known as binding. Okay, so Kubernetes looks for a PV that meets the criteria defined in the user PVC. And if there is one, it matches claim to your PV. This is called as binding. Okay, understood how do we make volume persistent in Kubernetes cluster? Now let me give you a use case. Let me go back to my notepad. Okay, this is my use case. I got a YAML file for creating an Nginx. For most important, I got this PV file created. So basically persistent volume. What are the parameters? Storage class name manual. Capacity. This PV will be of 1 GB. Access mode read write once, and on which host path, basically MNT data. So I don't have this path created. Let me get this path created. Okay, let me create this path. So it is mkdir. Let's go into the MNT first, cd, and I can have a path. What is the name of the paths? Mkdir data. Okay, let me permission deny. Let me use sudo. Okay, perfect. So I do have this path, cd data. Do we have anything in it for now? Nothing. Perfect. Okay. Second, so I got this PV created. The first thing, we have this PV created. Now we need to have a PVC created. So I have not created the PV yet. So what I have to do, I have to just copy this content, come to my server, create a file pv.yaml, paste it over here. Let's have a PV created quickly. Wait, where I am right now. Okay, let me go into DevOps Mela. Okay, let's have PV created. Okay, done. Now how do we execute this file? I can simply do kubectl apply -f pv.yaml. Done. How do we check if the PV is created? Kubectl get PV. Okay, so I got this PV created, capacity 1 GB, read write only, retained, status available, storage class manual, and the claim, there's no claim yet. Okay, so let's go to the second part. We need to have a claim created. Now I have got a claim file. Most important thing you will see, the storage class is manual, which is matching with my existing PV. The access mode is read write once, which is again matching with my existing PV. The storage requesting is 500 MB, wherein I got a PV, just one PV, which is of 1 GB. So let's see what happens. Let's come back. pvc.yml, have this. Now let's create this quickly. Apply pvc c, done. Now let me go and see the PVC quickly. PVC. So this is 1 GB capacity of PVC got created, and it is bounded. It is bounded with the PV what we have created. If you see the status bounded. Now many of you will say we have requested for 500 MB. Now how come it has assigned 1 GB? What did I say earlier, guys? Kubernetes will look for PV that meets the criteria, and if it matches the claim, the nearest claim, it will go and do the binding, and that is what the binding was done. Now just because this PV was of 1 GB, the complete 1 GB was given to this particular PVC. So if even though the requester asks for 500, this is the complete 1 GB was given. Now if you do things dynamically, so you can be very precise also. That's for part 2. Let's keep it for part 2. In part 1, just focus on this part. Okay, so this is how your volume will be persistent. Now how do we test it? Now I do have a pod. Okay, so this is my pod. Most importantly, this is an Nginx pod which I'm creating, and most importantly, if you see this volume segment, I got this PVC, and this is the name of my PVC. So basically the path mount data will be mounted on this. So this is the path wherein we can keep my index.html file in Nginx. Let's see if that works. So let me create a pod quickly. pod.yml. Let's create this pod. kubectl apply. Okay, let me. Okay, running. Let's go and describe this. Okay, created. Most importantly, if you want to see mount, the mount is created. Now, how do we test this? What I can do, I do have some index.html file over here. So let me show you what exactly it is. So welcome to DevOps Mela interview prep. What I'll do, I'll copy this file into my local directory, that is mount data, and we'll see if, okay, so let's verify this if it is copied or not. Okay, so it's there in my mount data, which is there on my local server. Now, how do we check if this particular file is visible in my inside my container or not? The best way to check will be I can run the execute command, or I can have a service created and I can check if this particular page is visible. Both the ways we can do, but let's go and run the execute command. Okay, what is the name of my pod? Nginx pod. Okay, then I can run a command ls user, where exactly it is mounted, user share nginx html. Oh, perfect. Do you see we got the html file? Now let's do a cat. Many of you will say that this was an existing file. html index.html. Okay, so if you see this, I'm running the execute command inside the container, inside the pod. Okay, so this is, now how do we test it if it is persistent? Very good. Let me delete this pod quickly. Nginx pod doesn't have the resource type missed pod. I always do that. Okay, get all. If you see, gone. The pod is completely gone. And can we go and check if my MNT data had this index file? See, the data is still intact because the data was stored on my local hard drive, not inside the pod this time. Hence, I was able to achieve such things now. With the help of volume persistent, I was able to achieve persistent volume in Kubernetes. Simple. Okay, now you guys can do persistent volume with cloud also. You can store your data on cloud on S3. You can make use of cloud controller. You can store it on Azure storage also. So this was a classic example which I showed you. If you want to store your data on your local hard drive. Okay guys, moving on. Okay, very interesting question. I need to provision a big data app pods on big data nodes only. So I got a big data node. Just imagine I got a big data node of very high config, 64 GB RAM, 16 core, and 2 terabyte of SSDs attached to it. So I got such big server created, and I want my all my big data apps, like all related pods, should be placed only on that particular nodes. That is one scenario. Okay. The other scenario is no other application pods. Again repeating, if it's not a big data pod, it should not be deployed on the big data node. How do we achieve this? Okay, understood? Two scenario. I got my big data app pods which should be placed only on big data node. Second, no other application pods should be deployed on big data nodes. How do we achieve it? That is the question. Okay, let's see it. The above scenario can be achieved through combination of multiple concepts. So I'm just talking about this first scenario first, that only big data app pod should be placed on the big data nodes. So this can be achieved using node affinity. Okay. Node affinity is a property of pod that attracts them to set of nodes. You can do either by preference or you can place it as a hard requirement. Now what exactly this mean? Node affinity is a concept similar to node selector. So basically it will allow you to constrain which node your pod can be scheduled based on node labels. So using this node affinity concept, what you can do, you can define which node your pod can be scheduled. So basically you can tell the scheduler with this node affinity that this particular pod which I am creating right now, this needs to be placed on this XYZ node. So the first condition will be achieved using node affinity. But can a node affinity deny other pods to be deployed on the big data nodes? The answer is no. With node affinity, your pods will know, your scheduler will know this pod needs to be placed where. But can they deny? The answer is no. If you want to deny others that others pod should not be placed on the big data node, then for doing that, you got something called taint and tolerance. Remember the second scenario in Kubernetes which we just spoke about? I was not able to place my pod, Nginx pod, and the scheduler was not deploying my pod on my master node. The reason was the master node is tainted. Now what is tainted and all I'll explain, don't worry. So taints are basically are opposite. They allow a node to repeal a set of pods. What exactly this means? Now let me give you a very layman example. Imagine a toddler is playing in a garden. A toddler is playing in a garden. Now what toddler's mom did, the toddler mom sprayed some mosquito spray on toddler so that the mosquitoes are not able to bite or harm the child. Okay. So with the spray, because of the spray, the toddler is tainted right now, and because of the repel smell, the mosquitoes will not bite the toddler now. So that is what tainting means. So just imagine some sort of spray on your node, and because of the spray, no other pods can be deployed on that particular node. Now, how do we, if imagine we want other pods to be deployed, how do we do it? Now, this can be achieved using tolerance. Tolerance are applied to pods. Tolerance allow the scheduler to schedule pods with matching taint. Now imagine take the same toddler as example. Now there are some few mosquitoes, they are tolerant to the smell of the spray which was sprayed on the toddler's body. They are tolerant, they are used to. It doesn't matter how many sprays you use, they can still go and bite the toddler. So that is what tolerance means. Okay, so tolerance, like if you still want your pods to be placed on big data node, in such cases you need to make your pod tolerant of the taint which has been used. If you do that, your scheduler will be able to deploy your pod on the big data node. So that is what taint and tolerance comes in picture. So using these three rules, node affinity, you can make sure the pods are placed on the big data nodes only. And with the help of taint and tolerance, you can make sure no other application are placed on the big data nodes. Okay. Note, taint and tolerance work together to ensure that pods are not scheduled onto inappropriate nodes. So they work closely just to make sure that the pods are not scheduled onto an inappropriate node. Okay, let's move on and let's move on to the sixth scenario and let's see what exactly it is. Okay, let's go and see the last scenario. So we got the scenario 6. Very straightforward question. What are sidecar containers and what is the purpose of sidecar containers in Kubernetes cluster? Let's go and see this. This is more like theory. So a sidecar are also known as composite container. So basically these are additional container that extend and enhance the main container. What does that mean? So sidecar container, you can call it as a separate container. It's a separate container that runs alongside an application container in Kubernetes pod. It's more like a helper container for the application. So sidecar containers have become a common Kubernetes deployment pattern and often used for network proxies and are used for logging system. Okay. The main purpose of sidecar containers, it can be used for batch processing, AI/ML workloads, network proxy, log collections, and many things. Okay. So a sidecar container, what it will do, it will allow you to enhance and extend the functionality of your main container without having modify it code base. So basically, you will have your application running in one container and there will be one sidecar container attached. The purpose of the sidecar container will be basically for network proxy. So there are many network proxy tasks such as SSL, MTLS, traffic routing, high availability. All this critical functionality of your application can be kept separate in which could be running on a different container. Or just think of you want to fetch logs, okay, from your application logs and you want to send those application log to somewhere, okay. So you can allocate this functionality, such critical task of shipping and logging and all this to a different container, keeping your actual application away from all this cider roles. So that is what sidecar container does. Now in today's scenario, in today's video, as I am teaching in scenario based interview question, I got some scenario for the sidecar container in place, which I will walk you through. But if you want to know details about how the things were set up and how the site container was created and things like that, then please do let me know in the comment box. I'll try to create a separate video wherein I'll show you how our sidecar containers are set. Okay. Definitely it is out of scope for the interview question, but just for the sake, I'm just showing you what exactly is the sidecar container is all about. Okay. Now let's go back to my cluster. Now in cluster, I've created a new namespace. So this is where my sidecar containers are. Now what exactly this is, how this setup is done. Let me show you a diagram first. So this is the diagram. So basically what I have created, I've created a Istio mesh. So I've created a service mesh. So I got one Java application Spring Boot running in one container. I got one application Node.js running in one container. And there's a traffic which is coming from outside. It goes through one more container. This is known as proxy. Okay. So it is network proxy. It is intercepting all the traffic. Okay. Post that the traffic is going to my application. I'm getting a response. Then these two application are interacting. Basically, this is my front end and this is my back end. Okay. So all this request is going through mesh traffic, that is MTLS. Then again, I got a container Istio service mesh over here. So basically, this is the Istio service mesh setup. So service mesh is nothing but it's a dedicated infrastructure layer that controls service to service communication over a network. Okay. So again, there's a network proxy which is intercepting the traffic and the request is going outwards. Okay. This is the setup what I have done it right now. Now, if you want to see the sidecar container, so this is the pod. Let me go and describe this pod. kubectl get describe. So this is in my prod namespace. Now, if you see the event container created Istio init, so the Istio initialization is happening. That is one container. The other container is basically my image. Now, it's creating a container using my image. So my image is basically on my Docker hub from where the image is getting pulled. Okay, so one container, this is one container. Let me go up. This is one container. Basically, this is my numeric app. Okay, there's one more container over here. See, Istio init. So this is my Istio services which is running. So I got two containers running inside one pod. Now if you go and see this again, I get 2 out of 2. So I got two containers running inside one pod. Okay. Same way over here also, if you go and see there are two containers running inside one pod. This is what called as sidecar containers. Now, all this I'm getting it from Istio systems. If you see, I got Istio setup done. Istio, Istio, no, it's Istio. Okay. Now these are the things Istio setup, which is running my Ingres Istio-D. All this is running, and basically it is now if I create any other pods in this prod namespace, automatically this network proxy will get attached to it. Okay, so this is what a sidecar container is all about, guys. So basically it takes out the important functionality from the main app. Okay, and it basically it enhances and extends the functionality of main container. And all these things such as service mesh, SSL, MTLS, network traffic routing, high availability, logging, shipping of logs, everything can be dedicatedly given to a sidecar container. So that is what a sidecar container is all about. So if you want a demo on how to set up a sidecar container, how exactly I've done this setup and all, please do let me know in the comment box. I'll 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 try to make a video, dedicated video on Istio. Okay. That's it for me, guys. If you have any questions, doubt, please feel free and put it in the comment box. You can reach out to me. Okay. And please do let me know if you need if you want a part 2 for this Kubernetes, then I'll definitely go try and create a part 2 video for Kubernetes scenario based interview question. Okay. That's it for me. Thank you for watching. And if you have not subscribed, please do subscribe to my channel, guys. Thank you very much. Bye bye.